18 segments making up the primary mirror on the James Webb Space Telescope will be held in place by something called a backplane. Since each hexagonal mirror is about 3 feet tall, you can imagine this backplane is really huge and very complicated to make. To find out more about how this is being assembled, we're here at ATK in Magna, Utah, and we're happy to have with us Bob Hellickson. He's the project manager for the James Webb Space Telescope. Thanks for having us over.
Thank you for coming to visit us, Mary.
First of all, how tough a job is it to make a backplane for the James Webb Space Telescope?
Well, what we're standing in front of right here is 3 of the full-scale hexes for the backplane, and this was manufactured out of wood that established both the tooling approach and the assembly approach that we'll use for the flight article.
Now, you didn't just go from this to the real thing, did you?
No, we did not, as a matter of fact. This structure was the first, made out of wood. Then this same size, 3 hexes, was made out of the graphite composite material. It was taken down to the 30 Kelvin level, or minus 405 degrees Fahrenheit, and it was measured for its performance on stability, meaning it had to stay very stable through that entire temperature regime.
So, Bob, I understand the real backplane is here at ATK now.
Oh, absolutely. We can show you that, and we'll have to go in the clean room next. I want to show you some electronic measuring equipment to make sure that everything meets its final dimensional performance before we deliver.
So is it like a GPS where it detects where that ball is located at any given time?
Yeah, that's exactly right. That ball coordinates back on its surface to where the model is for the corresponding feature.
This is very interesting stuff, but the suspense is killing me. Can we go see the backplane now?
Absolutely. Let's step around this side and we'll show you the rest of it.
Great.
This is the center section of the backplane, and it will house 12 of the primary mirror segments.
You said center section. It's not the whole thing?
Correct. The full-size mirror will have 18 segments, and what's missing here that'll come later are 2 wings, each holding 3 segments or 3 mirrors.
And why break it out into a center and 2 wings?
The launch vehicles don't have the dimensions to accept the entire width, so it has to fold up, and that's another unique feature here is we're deploying 3 of the hexes on each side or both wings.
This is not exactly a flat structure. It looks like it's got a little bit of a curve.
That's correct. The backplane matches the parabolic shape that they want the primary mirror to end up with.
Besides holding the mirrors in place once James Webb is in operation, what else is the backplane for?
The backplane also provides stability to the entire observatory. So what's missing here, you'll see later, is a backplane stability frame that reaches up about 8 feet off of this section. It will house the instruments for the observatory and provides a lot of the strength for the launch.
Well, thanks for showing us ATK's backplane.
Well, thank you very much for coming to visit us, Mary.
So as you can see, this backplane will be ultimately thermally and structurally stable, important for the 18-segment primary mirror to stay still so that the James Webb Space Telescope can take its wonderful images of the universe. Thanks for joining us for this edition of Behind the Webb.